Alright, good evening class. My name is Jimmy Velasquez and I'll show you my code for assignment 4 and that it works. Alright, first I will show you the result. As you can see here, the result that we get is almost exactly like the what's it called? The test results that we were given by the driver's CPP file. Alright, let's start with the header file for module. This one, the first thing we have to explain is the protected data that we have, the member data that we have. So this protected data will be used for the linear layer and relay activation files in order to to manipulate our vectors as needed. We have the default module here that sets our weight vector to 1. And then we have this Ford this Ford function for our module that performs element-wise multiplication of the input vector with weights. As you see here, we have a for loop and a vector double here that takes in the input of the size of the input and will churn out whatever that that vector as needed, how many times it needs to loop for. Then we have our linear layer header file. As you can see, we include the module.h for the protected class member data back in module. That we have our private member data's input size, which is just the the number of inputs, then the output size, which is just the number of outputs, and the vector double bias, which is just the vector bias, which we set to 1. I'll show you later. And here's our public functions, and I will show you how they work. Here's our linear layer constructor that initializes the input size to input size, the output size to output size, and the bias to output size, and 1. And we have the void linear layer set flat weights function here, which just gives us the the flat weight vector. And as you can see here, the new weights here will be into weights. The Ford function, which reshapes the flat weight vector into a temporary 2D matrix of dimensions output size times the input size, and does the computation per what I was instructed to from the homework file. You see here. So then we had the linear display function, which just prints out the expected weight dimensions, the bias vector, and the flat weight vector. And then we have the weight size const functions here. And this gives us the input size, or displays the input size and the output size. Then this just, what's called? I've added 2 things here. What these do is they get the input size and the output size, so that then we can later use it for for our neural network and block file. All right. Then I will move on to the to the next one. So we have header file for the ReLU activation. We have our private member data of double slope and double negative. Then we have our public functions here that I will show you. Second. So that. All right. Oh yeah. That, and then that. Okay. Alright. Here's our ReLU activation CPP file. What this does is a constructor that initializes the weight vector, so the first element is the slope for whenever it is more than 0 or equal to 0. And the second is the slope for when it is less than 0. See here. And then we have the forward function, which applies a Boolean function to each element in the input vector. You can see here. Then we have the display function, which prints the activation parameters, and then we have the set weights that updates the weight vector for the slope parameters. Then we have the block header file, which we have member data of linear layer linear, which is the linear layer component, and the Rayleigh activation Rayleigh, which is the Rayleigh activation component. Then we have the block constructor that creates a block with the specified dimensions for the linear layer. Then we have the forward function that just processes the input through the linear layer and then through the Rayleigh activation. Then we have the display function, which gives us the details of both components. The void size function, which prints the size information. Then the void set weights function, which sets a flat weight vector of the linear layer. And then void set activation weight sets activation weight for the Rayleigh component. Alright, now we have the neural network header file here, which is, we're given the private vector block for blocks here. Alright. And then, oh wait, no, very sorry. Yeah, neural network, okay, yeah. So this private data member blocks, it's a vector of blocks that make up the network. I'll move on to our neural network CPP file. So we have a neural network constructor here, which just builds a network as follows. If the number of blocks is less than 2, it creates a single block, mapping in size to outsize, or to what's called our output. So here, as you can see here, use StacyNet. And also, because of, what's it called? The friend class, we were able to use the data from the linear layer. Like, for example, so because the neural network class needs a direct access to the linear block here. So this data is shared with neural network from linear layer. That's from what I can use. So then we have the vector double neural network forward, the forward function, which just performs a forward pass through all the blocks sequentially. Then we have the print block sizes void function, which prints the size information for each block. Then the neural network print model here, which gives us the size information for each block. Then the set block weights just sets a flat weight vector for a linear layer of the specified block. And then we have the void set block activation weight, which is for the Rayleigh layer of the specified block. And here I will run it again just to show you that it works. As you can see here, it works just fine. And that will be it. Thank you for watching my video and have a good day.